Hello guys, this is Sabi. You're welcome to another episode of Networking in the Cloud. This is, as you can see on the screen, this is a left a this is a session from the previous video that I did on how to connect multiple accounts to the internet via a master accounts NAT gateway in different AZ using the transit gateway. What that means is that each account traffic, the multiple account traffic, or whether it's a single account or multiple account, but the the idea is a multiple account. But on in that video, I only did just a single account. So the idea is that the account traffic from AZ1 should go via the master's account NAT gateway AZ1, and then the AC2 also should traverse the master's account AC2 to get to the internet. So that was what I did. And if you have watched that video, if you have not, you can go ahead and have a look at it. The what I did in the previous video was to use a resource access manager to share the transit gateway to the other account because they have to be in the same region. They have to be in the same region. And but in this video, I've promised that I want you guys to see where you don't have to use RAM, which is a resource access manager, but let's say the other account is in another region, maybe the US region or any other region apart from Frankfurt. In this case, as you can see, I have the Oregon region here, which is the US, and the master account is on my left-hand side and the spoke account is on my right-hand side. So the master account is in the Frankfurt region, the spoke account is in the Oregon region. Whereas in the previous video, they are in the same region. So many people want to see how this is going to work, and I'll also use this opportunity to show you how inter-region peering of TGW also works. And the I said random, the Resource Access Manager, it's more or less like peering of TGW in the same region. Well, we won't really call it peering because the other account does not have a TGW. So, well, but if in case you just want to call it like that, is appearing in the same region, but not really appearing. But this one is appearing because in the Oregon region, as you can see, we have, let's go to the transit gateway. We have a transit gateway called TGW peer. In the other video, you see that there's no TGW there. It's not, we have to share it from the master account to the spoke account. So, and in these master's accounts, you see that I already have the TGW, which I used in the previous video. I called it STNO. So I'll be pairing these two TGW together. And then what we are trying to achieve is that I still maintain the same topology, the same infrastructure setting in the master account as per the previous video. But I just want to show you what we are going to be doing is that we're going to be coming from the AZ A of the account, the region in Oregon, and try to reach the internet. And we want to ensure that our traffic only goes through the availability zone A and not B. But when we are testing traffic from availability zone B, we want to make sure that our traffic is going to the internet in the master's account via the availability zone B. So that's exactly what we want to do. And this is a good thing because well, I've tested it, it doesn't matter. Many people will come with a question that, okay, I want to pair these two together. Do the ASN, do they have to match? Well, I've tested it with the same ASN, it still works, but I think AWS on the documentation says it's better to have the ASN with different numbers. And I would also suggest that you have them with different numbers. You can see here, I have in the spoke account, I have 64512. In the master account, I have 64533. It's better to just make them different to avoid any surprises. But I think I've tested it with the same and it still works. So the first thing we're going to do is to create the peering. Let's do the peering first, and we'll see. And just let me see if I can bring this up. This is just this is from the pre. Let's see if you can, I can bring this up and you can see on my screen. Yeah, if you can see this now, this is I just took this. This is and drawing. I just took this from the previous. I've not done lab on this. This is the STNO lab, which I might be doing. I might put up something like this very soon. If anyone wants to see this setup, you want to see how if it works, you can let me know in the comments, and I'll be happy to do a lab on that. And this setup is this is the master VPC. You can see I'm connecting to the VPN. We call this as the on-premise VPN. You can see this is a VPN connection. So if anyone wants to see this work, just let me know. I can put it up. This is the shared VPC to the same region. And I also have a TGW peering. So this part in blue pen in blue color is what I've done. I did in the previous video, and this part is what I'll be doing now, which is the one in the red color with the red color. Is the one I'll be setting up now with Oregon, as you can see here. So, and the TGW routes table for the master. This is the TGW route table for the master, and this is when I was using the STNO, but we won't really have much of this. But the only thing we will have is the flat network. This is a TGW route table, and we have different route table. We have different route table in the TGW. So don't be confused. These are TGW route table, TGW route table, TGW route table in a single TGW. So let's go ahead and set something like this up. So we already have this. We have TGW here, and we have another TGW here. So we are going to have a pairing between them. So you want to quickly take a screenshot of this? You're welcome. So without further much ado, another thing many people, when they think, oh, TGW pairing, they just go to the next thing they do is to go to, where is that? They go to peering connection. No. You do the TGW peering from the transit gateway attachment. Now, this is from the previous attachment, the previous lab that I did. So you create an attachment because it has to be an attachment. And this is where you choose peering connection. I choose the TGW ID, and it's got in the name. You can say peering, or you give it any other name, and we know this is going to a different account, which is peering to other accounts. And of course, we have the same account there, but in this case, we are going to a different account in a different region. So we want the account number for this one, which is different from the other one. So we're going to I already have it copied somewhere. So we want Oregon. And Oregon, I think I've passed it, right? Oregon is US West. And the TW acceptor, we have to, this is the one that will be accepting. So this goes there. And we are making, so it doesn't matter. The spoke can create the peering to the master can create a peering to the spoke. It doesn't matter. So once this has been created, what we have to do is to come to the attachment here and see if, yes. So we can see that there's a person for us to come here and accept. So, oh, okay. I don't think initiating request, yes. Yeah, we still need to action accept. So accept, we just give it a time. It's asking that, do I want to accept this? I said, yes, I want to accept. And we will see something like pending, creating the attachment. If you, yes, creating the attachment for this, and we should also be seeing this should change to pending acceptance. This should also change very soon to to available. Once it's available, you'll see that. And Forgive me about the lights. I know I just have to keep saying this over and over about the lights. So you might not be able to see my face very well. I had to do this in the middle of the night. This is the time when the children are already sleeping, so they don't disturb you. And I think I had to do something about the light anyway. But like I always say, what's important is what you're seeing on the screen. Just trying to put the face to what I'm doing, so it will make sense and you'll be able to see the face. It's nothing serious. So we should be able to see that the pairing is now available. Okay, it's dependent, but it doesn't matter. So once this is done, what we want to do is to come to the route table. We see that this is still pending, but very soon it should be finishing. So this has moved to pending also. So we just need to wait for this to be available so we can move on with the next thing that we need to do. So the next thing we need to do is to set the route table for the spoke. Now we can see the route table. I think at this point I'm just using the default VPC here, which is 31 network. And we can see the route table for this is to have, we need to be able to reach the peering for the on the master cider is 10.0.0. That's, we can put the old cider. If you look at this closely, you see that this is 10.0.0/16. We can see the association part, which is we have the peering VPC, we have the peering connection attachment. And at the route side, we have that we want to be able to reach the 10 network, that should be going to the peering. And the 15 network, that was from the, if you look at this is the spoke, but we don't have that there. It's in the previous, I explained this in the previous video. So but what we're concerned about is, and we are not even going to this network because that is for the VPN, but the only network that we care about is the peering network, which is the master's account here on the TGW side, and we still need to go to the VPC side to also set things right. And so, and that is what we'll be doing. So coming back here, we see this is already available, and definitely this also will be available. So like I always say, we need to set things right in the route table first. Association, what association do we have? We have, so the pairing is already here. It's already associated to this. So we need to create another association for the VPC. So we need to create attachment first. Yes. We don't have the VPC attachment for this, so we need to create an attachment for the VPC. Yes, we select this, we give it a name. So this is the VPC. We select the VPC, and we have the availability zone, the subnet where we want the ACs to be created. Let me just move this over to the side and create this and turn this back. So once this is created and is completed, we should be able to have the, once this is in available state, then we should be able to create an association, because you want the VPC and the peering to be associated together. Then that is when we need to go to the other side and fix that. And the mistake that many people do make, and this is good for troubleshooting purposes, is that when they are dealing with transit gateway, of course, they set the transit gateway route table and they forgot to go to the VPC route table to set things right. And by the time they try to test traffic, it's not working, and they mess things up, and it becomes a very serious headache. So you bear in mind that anytime you set this up, there are two places you need to configure for the routing: the TGW route table, which sometimes can be complex, and the VPC route table. And TGW route table, it's easy to understand once you know that you control things with the association and the propagation. Anything that is in the propagation goes into the route table. If you don't have anything propagated and you want that particular route to be shown in the route table, then you create a static route for that. But there's no resiliency. There's no resiliency on that. There's no redundancy on that, because even if you have another route, even if you have another path for that particular route, but you created it statically, if that path goes missing, or maybe you have a very good example, you have a VPN connection. I'm saying this while I'm waiting for that to be done. You have a VPN connection, and is a static VPN or the BGP VPN, and you put it there. If the VPN goes down, the route does not automatically remove itself because you statically put it there, and it can cause issue if you have another path. But if it's a BGP dynamic, it will show in the propagate third tab, and it will automatically be in the route tab. So once this is taken off, you'll see that it will also be taken off from the route once the VPN goes down. So let me refresh this again, and we see that this is available. Good. So we go to the route table, and we can be in the route table while we associate the VPC. You can see we have the VPC here. We uh, okay. I think I saw that also. I was just like, oh, you know what? I was wondering why is this getting because of this. Yeah, I was wondering why the automatic association and propagation. Because you remember when I created the peering, I just saw it here and I was like, why did this come here? Because automatic. I don't like automatic stuff. Not that I don't like it, but I like to do things so that I know what's broken, especially when it comes to configuration. I like to set things myself. So when it's broken, I know what caused it. And this is because I'm using the default route table. I can change it, but you know what's going on. So the propagation should is there in this. I think for propagation, you can propagate a pairing. Yeah. That is why in the route table, you have to manually put it. See, a peering connection cannot be automatically propagated. And this is exactly what I explained. Because it's not at the propagation tab, you won't find it in the route table. Then you have to statically create it, which is what we're going to do because we want to go to the other side of the network, which is 10.10.16. And we know it's only available via the peering. So we create the connection, because we want to be able to reach that. So let's say you have another path to 10 network. You have the same path. If this fails, and let's say for one reason or the other, this is your primary. If this path fails and it turns to to black hole instead of static, then you might have a problem. So anything you statically put in the TGW route table, just bear in mind to always check up on it, especially when you have a secondary part to it. Okay, let's get going. I think I talked too much. If I'm not talking too much, then what's the purpose of this training? Okay, so where are we? What do we need to do here now? So this already set. I have the spoke and I have the master, but I don't need the spoke in the sense. This is for the previous lesson. Let me just do this. because the master is the real deal. The master is the real deal. I need to do association. I need to associate the peering. So we need to associate the peering and the propagation. Like I said, it shouldn't be there. So we just need to come here. The other side of the, that is 172.1/16. But you might decide to choose the exact subnet, but just to save us, just put the old thing. Where we are trying to go, I almost even forget. We want to test this. We want to test the internet connection. You want to be able to test the internet connection from this part to this part. So we want to test the internet connection coming from here, the other account going through the TGW here, and we have I should have an internet part in this traffic going to, I can decide to put it all traffic, but so that you can know what I'm really testing. So this attachment. So you see, if I need to reach this, which is the other side, I go to the parent. If I need to go to 888, I send it to the VPC, right? Because the VPC attachment it knows how to get here, there. Now, in this situation, I should be refreshing. This is what I'm looking for so that I can have my 888, because, when you create a static route, sometimes it does not automatically appear there, so you have to refresh it. I need this one in case I'm trying to get some resources within the master's VPC. But if I'm going to the internet, this is what I need to send to the same path. And this path, send it upward to, okay, before I move to the master VPC, let me just fix the other side of the uh, of this, of the Oregon VPC. So I have this. Now I don't know which. I hope all the subnets are in the same route table. I have a single route table for them, so that's fine. Let's reduce my work. So I can come here and say, what do I have here? You see, I'm not trying to go here. I should have removed this. Ignore it. Just pretend as if you never see this. This is fine. I'm going to the TGW, and this is for the VPN, but I'm not really going there. Another part I'm going is this, the pair. So this is set. We're good to go here. So the master account, we can jump to, I don't really need to do anything here as it's where. Yeah, I don't really need to do anything here because I've already said it, but I can just go ahead for the sake of those that do not understand. I mean, for the sake of those that do not, but I highly recommend that you just go and check the first video, then everything will make sense. I don't want to make this video long, so I don't want to go back, but let me just show you what I have here. I have two private subnets. I have two private subnets and I have two public subnets. This is where the private subnets are pointing to the NAT gateway that I created in AZ1 and AZ2. And the internet subnet are the ones that actually connect to the internet gateway to take the route out. So what I'm going to do here is that I'm going to go to I'm going to change this now to Oregon. I'm going to create, I have two instances. We should see two instances there. To go to, so we can see the instances that I have here. I have peer AZA, AZB. You can see this is indeed A and this is indeed B. And that's all that we need. And this I'm going to, we need to quickly confirm this route table if I have, okay, I have so I can launch in, I can log into it because I won't have access to the SSH. But this is where I'm really going. So let's do that. So as you can see, this is the first instance AZA, but to just check that, let's cross check to see that the IP address actually tally for AZA, and we have 31.42.50, 31.42.50. So just for us to test, I hope someone will be able to tell me why I'm not able to reach, and that is why. Okay, let me fix this first, then I'll explain what I want to say. Uh, that is why I always say, okay, let me explain it. That's why I always say, when you finish doing all this thing, there are two places where you need to first ensure that your TGW route table is properly set and your VPC route table is also properly set, because you can run into a lot of things here. So for the VPA, let's just check what is wrong. We turn this into a troubleshooting session. So we can see here that we don't have a return route back to 172.31.0.0/16. Let me just put it like that, to the transit gateway. We don't have a route back to it. So because I'm originating traffic from there, that's why it's failing. I want to believe. So if we, and yes, again, don't be in a rush, because private AZA is going to send the traffic to private internet AZA. So that also needs to be fixed. So let's just, while we are at it, let's just quickly do for the AZB so that we know we are done with that. I'm just acting a little bit lazy by putting outside up there, but you know, if you want to do this with the with the exact subnets, why not? I think this one. Why not? You can just do that with exact subnets instead of trying to be doing it lazy as I am doing it. So now that we have this setup, let's try again. You see. Oh, this is already working. So somebody, this is for the B, this is for the A. Someone might say, wait a minute, are we sure this is not going through the internet? Because you already have an IDW there. So for us to confirm, let's just do a trace route. Let's see. Now this is easy A, right? So let's see where we're going. Now on the NAT gateway, let's see what AZA private IP is. 4221. What do we have on the first up? 4221. So jump into the AZB part. Let's see where this is taking. Okay, this is still going to AZ1. That's exactly what we want to see, but sometimes it might be that the AZ1, AZB is the closest to the. So sometimes when you see something like this, because when we did the one on the Frankfurt in the same region, it's doing exactly what we wanted it to do. But this, in this situation, we see that AC B in the Oregon is still trying to use most of the traffic on AZ1. This happens when the availability zone A is actually closer to the US region B. In the US region, the B, the A of because they are this is interregion now. So the location where the availability zone, where the availability zone for the Frankfurt, which is the AZ A is closer to the availability zone of AZ B. So which we don't really have control over that. So this is the situation where you see that most of the traffic is going through the AZ1, not really doing what we wanted it to do. You can see that this one is going to the AZ B here, but you see that it's not. We don't see much of the traffic here, and okay, that the second traffic we can see it's going through the AZ-B, and we see now it's getting consistent. Yeah, we can see it's getting consistent now because that's the way it's actually supposed to be, but it's not something we entirely have control. Now you see that it's changing. That's the idea when you, but this work very well when you are within the same region. So if you can check the previous video to see this. Okay, so but you get the gist of it. You understand what we're trying to do. So this is the interregion peering, which I've been able to show you how the interpeering work. And if you want to troubleshoot this kind of connectivity, you see how at first it didn't work, but I realized that there's no return path because you need two places to set the route, the TGW route and the VPC route. And of course, your NACU, your network ACL, and the security group should be set properly. And I'm sorry, I'm not looking directly to the camera because I have another screen where you are looking at. So that's why I'm facing that part most of the time. But thank you. Please subscribe as I'll be showing more of these labs, and think I should be doing some. I still need to do the STNO, but I don't know if many people are starting to use it. It's just an automation way of creating your TGW, sharing your TGW, just like the first one that I did, but an automation way of sharing it instead of you manually sharing it. So it's a cool feature, but yeah, that's it from me. And you can give a shout out. Let me know which video you would like me to put up as part of the networking in AWS. I hope you enjoy this. Thank you.